Okay, let's revise matrices quickly in 5 minutes. Okay, so in matrices, what all do you have? You need to know how to add one matrix with another matrix, matrix minus another matrix, a number into a matrix, and a matrix into a matrix. Okay, these are all the four types of questions over here. Okay, the addition of matrices, easy, right? Every term of the matrix you will add with every other term. Subtraction also the same. For example, 2, 3, 4, 7. If you're adding it with 2, 1, okay, how do we add this? Hmm? You can't add this because the order of the matrices are not same. See here, what is the order of this matrix? Huh? Order means you have to say like this, 2 by 2. Not 2 into 2, 2 by 2. That means 2 rows, 2 columns. What's the order of this matrix? So 2 by 1. Okay, you can't add these matrices, you can't subtract these matrices because their order is not same. Okay, so remember, for addition and subtraction, order has to be same. So let's make it of the same order. We'll make it 2 by 2, minus 4 and 0. Okay, so now tell me the answer. First 2 plus 2. Okay, next Amma, tell me the next one. This and this. Match it. It's the same. Huh? Minus 1. Next. Well, 5. Come. Okay, next one. 7 plus 0. 7. Addition of matrices, which is revising matrices. Okay. All right. So this is addition. Subtraction also the same way. All right. Let's change this to subtraction. Tell me the answers now. Okay. 2 minus 2. Aman. Next 3 minus 4. 7. Next Arush. 4 minus 1. 3. Clear? 7. Okay. So addition and subtraction is same. Next, number into matrix. So it's a single number like 2 multiplied with the matrix. 5, 0, minus 6, 3. So you'll multiply this 2 with everything. It's like brackets, right? So 2 5s are 10, 0, minus 12, 6. Okay, that's easy. Next, matrix into matrix. 2, 3, 5, 6 multiplied by 7, 3, 2, 6, 4, minus 5. Okay, so to multiply two matrices, what should be the condition? Okay, so let's see this one's order. This one's order is 2 by 2. This one's order is 2 by 3. To be able to multiply two matrices, this number, that's a column of the first matrix, should be equal to the rows of the second matrix. That's the rule. Okay, these two numbers should be same. So they are same, so we can multiply. Okay, now how do we multiply? First row, first column. Then first row, second column. Then first row, third column. That is to get the top three positions. Okay, before that, the answer, the resultant matrix will be of this order, 2 by 3. That means 2 rows and 3 columns. Okay, so this number here, 2 and 3, tells you the order of the resultant matrix. Okay, so that means you have 1, 2, 3, 1, 2, 3. Okay, to get this first position, what you'll multiply? Yeah, the first row here and the first column here to get this. Then to get this, first row and second column. Then to get this value, first row with third column. Okay. Next to get this, how do you get this value? You will multiply second column with the first row. Okay, wait. Let me just break it down for you. Now, each of these positions has I mean, they have positions. Like this one's position is first row, first column. Right? It's in the first row, first column. So it's 1, 1. This one is first row, second column. So it's 1, 2. This one is 1, 3. This one is 2, 1. Second row, first column. This one, second row, second column. And this is second row, third column. So these are the numbers you will look at the question to get it. So 1, 1 means to get this value, you have to see the first row, first column to get this value. To get this value, okay, here 2, 3. What do you have to do? Second row, third column. Okay. All right. So let's do the second row, third column and see what this answer is. So the previous step, you'll have to solve this. Okay. So how do you solve this? 5, 6, and 2 minus 3. First, 5 into 2 plus 6 into minus 5. Right. That is the calculation you have to do. So 5 2s are 10. 10. This is minus 30. 10 minus 30 is minus 20. Do you understand? So this is what you'll be doing for every term in the matrix. Oh, any doubt? Okay. Just note down whatever you have to note down.
No, can you explain that formula to me? That A plus B is equal plus 2AB, something like that. Right.
Yeah. Okay, done. Look at this question 14. Given A is given, B is given, C is given. Find the matrix X such that A plus 2X minus, I mean, A plus 2X is equal to 2B plus C. So they've given an equation with A, B, and C given. You have to find X. How do we do this? So we write our equation. Tell me what should we do? Should we substitute the matrices here first, or should we make X the subject first? Huh? Okay, we'll make X the subject. We can't make X, we'll make 2X the subject. Okay. So we'll take A on that side. So we have 2X is equal to 2B plus C minus A. So now here we can substitute the three matrices, solve this whole thing, and we'll get 2X is equal to one single matrix. Right? After doing the addition, subtraction, multiplication, all that. Now we have to find X. So we'll take the 2 on that side. So what happens when you take the 2 on that side? You'll get 1 upon 2. Divide. The same thing. Either 1 upon 2 or divide by 2. Which means every term should be divided with 2. Correct? Every term that you get. For example, if this is 10, 6, 2, and minus 6. Okay, so you have to write it like this. Instead of writing upon 2 over here, write it as 1 upon 2. It's the same thing. So you're multiplying 1 upon 2 with every term. So 1 upon 2 into 10 is what? 5, no? 2 and 10. It's the same, no? Divide by 2. Next term will be 3. Then 1 minus 3. Okay. Then you'll get decimal point. Okay, so mostly you will not get odd numbers. It will be even numbers so that you get whole numbers. Okay, that's how all the questions are in your book. Decimals never come inside this. But if it comes, I mean, if it's odd, it will be decimal. Or write it as a fraction, whatever. So remember this, okay? In the first step itself, don't take the 2 that side. When do you take the 2 that side is? After you get a single matrix. Okay. Everyone clear with that? Now there is something called transpose, right? Suppose matrix A is 2, 1, 3, 7, minus 4, minus 8. Okay, what is 8 transpose? Huh?
The
Yeah.
rows become the column.
Come on. Nathan, what did he say?
And the rows become the column. Like the first row, it becomes the first column.
Yeah. So here the first row is 2, 1, 3. That 2, 1, 3 becomes the first column here. Second row is 7 minus 4 minus 8. That becomes the second column. 7 minus 4 minus 8. Understand? Yeah. Now, can you multiply A with A transpose? Small t or capital T? Small t, I think. Can you multiply A with A transpose? Hmm? Yes. Why? The order of this matrix is 2 by 3.
2 by 3.
This one is 3 by 2.
3 by 2.
You see, 3 and 3, same. And your answer will be of which order? 2 by 2.
2 by 2.
So let's try to solve the answer for this without doing the middle step. Okay, in the mind itself, try to calculate. So whenever you do multiplication, write them side by side so that you won't get confused. No place. Okay, so now 2 into, see, you have to imagine first row and first column. Okay, so 2 twos are 4 plus 1 plus 9. 4 plus 1 plus 9. If you want to write that step, 4 plus 1 plus 9. Okay, the next step you can write the answer, that is 14. Okay, next one, to get the next value, we have 3 values here. No, 2 here and 2 here, correct? Okay. Next one, first row with second column. Hmm, 14 minus 4. Minus 24, no? 4 into minus 8. Come on, tell. I want you to talk. Okay, next step. How 49?
Second row with first column.
Second row with first column. So 7 into 2.
Minus 24.
Minus 24. Right? Minus 8 into 3. You saw it or not, Aman? Okay. Last one, Leah. Tell. Second row with second column, no? 7 into 7. 49. Plus 16. Because minus 4 into minus 4. And then? Plus 64.
Plus 64.
This is your second step. And then your third step, you write the final answers. 14, here 14 minus 4 is 10. 10 minus 24, minus 14. 14 minus 4, 10. 10 minus 24, minus 14. 49 plus 16, plus 64. 129. Okay. So you can always multiply A with A transpose, like a matrix with its transpose, because the rows and columns will match. Okay, what is matrix I? I is made up of ones and zeros, but where are the ones is in the leading diagonal. Leading diagonal means it starts at this corner and ends at this corner here. Okay, so if it's a 2 by 2 matrix, then it will be like this: 1 0 0 1. If it's a 3 by 3 matrix, you see the leading diagonals are ones, remaining everything is 0. Okay, so such a matrix which has equal number of rows and columns is also called as square matrix. Okay, so this I matrix, or also called as identity matrix or unit matrix, will be a square matrix with the leading diagonal as ones. Is that clear? Okay. Now,
Now, where do we use this I?
they'll give you in the question. For example, see here 22, they gave I. Okay. And I was also used in the equation. Sometimes, most of the times, they won't give what is I. You just have to figure out based on the order of the matrix. Where is that? Okay, anyway, see this question here. 22. A is given, I is given, and A square is equal to 2A is 2A plus Mi. Find M. Okay, so I matrix is one of the matrix that is used in the equation. Okay, now we found X in the previous question here. Okay, X was, sometimes X will be just alone, like plus X added. So then you can just take everything to the other side and find X. Sometimes X will have a number multiplied with it. Then we do like how we did here. Sometimes X will be multiplied with another with a matrix. Will X ever be multiplied with another matrix? Yes. Look at this 23rd question. A is given, B is given, and here they're asking to find X. Look at this. A is multiplied with X. So you can have like that also. The X that you're finding, it could be added with something, with a matrix. It could be multiplied with a number, or it could be multiplied with another matrix. So how do we do this? Here you cannot just make X a subject. See, you have AX is equal to B. To find X, if I take A on that side, what will I get? I'll get B divided by A. And A and B both are matrices. We don't know how to divide two matrices. Correct? So this is not how you will do it. Okay? You have to figure out an order for matrix B. So what is the order of matrix A? This is matrix A. What's the order? Huh? 2 by 2. What is the order of matrix B? 2 by 1. Okay. So using these values, you have to figure out what the order of this matrix will be. Okay. Now, since you're multiplying these two matrices, this first number should be how much? 2, because these two should be same. Then only you can multiply two matrices. And what we also saw is that this 2 into this number here will be the order of the answer. So what is this number here? 1. Okay. So you have to write that as a statement. Rows of X equal to columns of A. Rows of X will be equal to columns of A. That is 2. Next.
Now, can you explain that once again?
This 2 and 2 should be same, right? That's the only way you can multiply two matrices. That is the condition to multiply two matrices. Yeah?
Yes.
So that's how we know that the rows of X is 2. Got that?
Yes.
Next. This 2 into this number here, the green ones, will be the order of the answer. Yeah.
Yes, yes.
So that's how we
Got
get
it.
one also. Okay. We just have to write it though. Okay. So rows of X will be column of A, and column of X will be what? This one. That is column of B. Just write it. This does. It's hard to understand what we have written here, but just write what how we figured out. How we got the two? It is same as the column of A. How did we get this one here? Column of B. Okay. So write it as a statement like this. Next, therefore take X as, we know it has two rows and one column. Two rows and one column. So take it as A and B. Put some values for it. Or X and Y, something. Then you put this into your equation. Okay. So AX is equal to B. So A into X equal to B. Like this, you put, you'll have A and B over here. Everywhere else you'll have numbers. Okay, so this is multiplication of two matrices. So you'll get two equations. First row into first column is equal to this first value. And then second row into first column will be the second value. You'll get two equations with A and B. Simultaneously solve them and find A and B. Is that clear, everyone? Understood or not? Now in this question, they gave this first matrix as sine and cos. Do you remember this table? Hmm? What is sine 30? Okay, so I'll just remind you with the table. This is from trigonometry, which we'll be doing later on. So 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. Sine, cos, tan. How much is sine 0? Tell me all these values. First is 0, then 1 upon, without looking. Okay, then 1 upon root 2, root 3 upon 2, 1. Cos values 1, root 3 upon 2 is the reverse of the this one. 1 upon root 2, 1 upon 2, and 0. Tan will be sine upon cos. Starting with 0, last value is infinity. Middle value is 1. Here you have 1 upon root 3, and here it is root 3. Okay. So these values you will apply here. You will get this. And B matrix is 4, 5. Okay. Understood how to do this? First row into first column will be 4. And second row into first column will be this 5. Two equations. Okay. Any more doubts in matrices, or we're done with matrices? All right.